Consider the series ln x plus p into ln x plus 1 by 3 into ln x and so on, where x is a real number and also it's greater than 1 and p is real number. At the same time, p cannot be 0. Consider the case where the series is geometric series. If it is a geometric series, we know this, there would exist a common ratio. And we need to show that for part 1, p is plus or minus root 1 over root 3. So whenever we talk about a geometric series, there would exist a common ratio. That is basically the second term over the first term, p into ln x over ln x would be equals to the third term over the second term. So 1 over 3 times ln x over p into ln x. So here all these ln x can get cancelled out. So I will just get it as p is equals to 1 over 3p. And when 1 over 3p goes to the other side, so it's going to be 3p square is equals to 1. And p square would be equals to 1 over 3. And whenever the square goes to the other side, it's not just square root. It will become plus or minus square root of 1 over root 3, which we can also say it as plus or minus 1 over root 3. And this is what we need to prove it. And now, this would carry 3 marks in total. And the first mark is for finding the common ratios. So showing up this particular step. So p into ln x and these things. Oh, this carries only 2 marks, not 3 marks. 1 mark is for this. And the second mark is for, let's say, showing up this p square equals to 1 over 3 and stuffs. Or basically this step or this step. So that would carry 1 mark. So overall, it's a 2 marks for this part. And for part 2, given that p is greater than 0. So when I say p is greater than 0, so that means the value of p has to be positive 1 over root 3. And the sum to infinity is given, and we need to find the value of x. We know this sum to infinity, the formula goes something like a over 1 minus r, where a is the first term and r is the common ratio. So in that case, sum to infinity is given as 3 plus root 3. And 3 plus root 3 would be equals to a. A is just ln x, which is the first term, over 1 minus r. R is the second term over the first term, so which is nothing but p times ln x over ln x. So your ln x and ln x can get cancelled out. We need to get the value of x. So that's why I'll be sending this 1 minus p to the other side. So I'll be getting 3 plus root 3 multiplied by 1 minus p, and this is what is equals to ln x. And from here, we have to substitute the value of p first, then try to simplify for x. When I substitute p, so p is nothing but we got it as 1 over root 3. So I'll be having 3 plus root 3 into 1 minus 1 by root 3. And this is what is ln x. So if I simplify this separately, so it's going to be 3 plus root 3 into 1 minus 1 by root 3. When I expand it, so 3 times 1 is 3, then minus 3 by root 3, then positive root 3, then minus root 3 by root 3. And 3 over root 3 is same as just root 3, so that's why these two things can get cancelled out. And this is basically 1, so that's why we will just get it as 2 is equals to ln x. And whenever ln goes to the other side, it becomes an exponent. So that's why it's e square is equals to x. Whenever ln goes to the other side, it becomes an exponent with a base of e. Now, this part would carry 3 marks in total. And the marks distribution goes something like this. So 1 mark is for showing up this substitution in the formula. And the second mark is for getting the expression either ln x equals to 2 or ln x equals to 2 or some equivalent step. And the third mark is for getting the final answer correct. Now for part B, we are talking about, now consider the case where the series is arithmetic with a common difference of d. Show that the value of p is 2 by 3. So whenever there is a common difference means the second term minus the first term will be same as the third term minus the second term. So that's basically p times ln x minus ln x, second term minus the first term will be same as third term, which is 1 by 3 ln x minus the second term, which is p times ln x. And I can take ln x common out here. So it's going to be, if I take ln x common out, I'll be left with p minus 1. And here also, if I take ln x common out, I'll be left with 1 by 3 minus p. And both the sides I can cancel out ln x and ln x. Next, if I take this minus p to the left-hand side and this 1 to the right-hand side, I'll be getting p plus p is equals to 1 by 3 plus 1. So which is nothing but 2p is equals to 4 by 3. And p is equals to this 2 goes and get divided by or multiplied with the denominator. So that's going to be 4 over 6, which is same as 2 by 3. And this would overall carry 2 marks, sorry, 3 marks in total. And the 3 marks go something like this. So 1 mark is for showing up this particular step. So actually there is 2 marks for this step. And 2 marks is for this step. And 1 mark is for cancelling it out ln x and getting these types of steps. So that's how the 3 marks are distributed for this part 1. For part 2, we are talking about write down the value of d in the form of k into ln x, where d is the common difference. So common difference is the second term minus the first term. Second term is p into ln x, and p is nothing but 2 by 3 ln x minus the first term is going to be just ln x. And here if I take ln x common out, it's going to be 2 by 3 minus 1. And if I simplify this, 2 by 3 minus 1 is, so if I try to make the denominator the same, so I'll be getting minus 1 over 3. So that's why this is same as minus 1 by 3 times ln x, where the value of k is going to be minus 1 by 3. And this would carry 1 mark. Next, if I talk about part 3. So now this part 1 carried 3 marks and part 2 carried 1 mark. So part 3 would carry 6 marks. So that's how the overall 10 marks are distributed here. So for B part 3, we are talking about the sum of first n terms, which is Sn, is given as minus 3 times ln x. And we need to find out what is the value of n. And we know this, whenever we have an arithmetic series, the sum of n terms is going to be n over 2 into 2a plus n minus 1 times d. Let us substitute it. We doesn't know what is the value of n. So it's going to be n over 2 into 2 times the value of a. A is the first term, which is ln x plus n minus 1 into, and we just got the value of d from part 2, which was minus 1 by 3 into ln x. And this entire statement will be equals to minus 3 into ln x. Now, if I simplify this, and here I can basically take ln x common out. If I take it out, so it's going to be n over 2 times ln x into 2 plus n minus 1 times minus 1 by 3 is equals to minus 3 times ln x. And both the sides I can cancel out ln x and ln x. So it's just going to be n over 2 times. And if I multiply this minus 1 by 3 inside, so it's going to be 2 minus n by 3 plus 1 by 3 is equals to minus 3. And if I also multiply this n by 2 inside, okay, before that, if I add this 2 plus 1 by 3, so that's going to give me 2 plus 1 by 3 is nothing but 7 by 3 minus n by 3 is equals to minus 3. So from here, if I simplify this, so it's going to be 7n over 6 minus n square over 6 is equals to minus 3. Because we have 6 and 6 which are same, so that's why we can also send it to the other side. So when I do that, I'll be getting 7n minus n square is equals to minus 18. When these things comes into the left-hand side, and also if I arrange it in the form of quadratics, I'll be having minus n square plus 7n plus 18 is equals to 0. And I can separate it with 9 and 2. So I can do it as minus n square plus 9n minus 2n plus 18 is equals to 0. How did I get this 2 and 9s? So we have to multiply the coefficient of first term and the third term. So that would be minus 1 times 18, which is minus 18. Now we need to think about finding the factors for minus 18 in such a way that they should add up to give me 7. And that can happen with positive 9 and minus 2. So when I do 9 minus 2, we can get 7. At the same time, 9 times minus 2 would be minus 18. So in that case, this is going to be, so if I factorize it, so that's going to be, if I take minus n common out, so that's going to be n minus 9. And here, if I take minus 2 common out, it's going to be n minus 9 equals to 0. And we can factor out further something like n minus 9 times minus n minus 2 equals to 0. And whenever the product of two factors are 0, we can either say n minus 9 equals to 0 or minus n minus 2 equals to 0. In that case, either n is 9 or here I'll be getting n as negative 2. We are talking about the number of terms. The number of terms cannot be negative. So that is the reason n equals to 9 is the only answer. And this is the final answer. And the marks distribution for this question goes something like this. So 1 mark is for substituting or basically showing up this one. So basically this statement would carry 2 marks. If you just shown this left-hand side, Sn is equals to this left-hand side, you would have got 1 mark. And if you have equated them, you would have got another mark. So that's how the 2 marks are here. And the third mark is for writing the equation without ln. So that's basically cancelling it out, the ln thing. And the fourth mark is for writing the quadratic equation. So getting down this quadratic equation, fourth mark. And the fifth mark is for getting this factorized form. And the final mark is for getting this value of n to be 9. And this is how the 6 marks are distributed for this sum.